Hi, this video is a quick overview of how I am approaching the programming skills portion for the 2017-2018 Ringmaster game. I'm a coach with a couple of fourth grade team members. This is our first year participating in VexIQ, and it's just taken us a very long time to understand how to approach the programming skills challenge. So the first portion, I thought we would just take a look at a recording of a program that we ran today. So what we have is this robot is Stretch with a couple LED sensors attached to the top. And let's walk through the program. So Stretch runs from the starting position, runs all the way down the length of the course, pivots, lifts up the claw to clear the wall, hits the wall to reorient itself, then backs up and presses the first bonus tray lever, and then pulls forward, hits the wall again to reorient itself, and then reverses to hit the second lever, and there we see the bonus tray being released. So with this, let's jump over and take a look at the program that we're using. So here's a program we're using. This is Graphical RobotC. Just the logic is I think it seems to be a clearer path to a lot of members to grow into full RobotC. First thing I want to note is that there are no sensors being used in this program. That with the younger team members, they want to bring out the gyro and the distance sensors, and this is just pure dead reckoning. That you just tell the robot to go so far, turn, go so far, turn, go so far, do something else. So let's kind of just walk through what we have here. So we start with a repeat forever, and so what this is doing is we have option to have two different if loops that can be started with the LED touch sensors. The logic here is create a program for the first LED sensor that would go down and try to hit both levers, and then have a backup program so if it hits lever 1 but misses lever 2, that we could build out this section that we could pick up the robot, put it back into the starting position, and hit LED 2, and then we go straight down and try to hit lever 2. So the program just starts out. So green are comments that we need to get that claw off the floor. Then we drive down the distance of the course. Then the next thing we do is we drive into the wall. That over this long run, the robot drifts to the left or the right, and we're not really sure where it ends when it gets to the end of the drive. So by running into the wall, that the robot reorients itself so we know its starting position. The trick here is this last step is you have to drive forward in seconds, because the robot will run into the wall and keep driving for 3 seconds. And when it is done driving that distance, that then it will go on to the next step. If this is forward and then you did rotations, and you have forward 3 rotations, the robot drives forward 2 rotations, hits the wall, that it will be stuck because it'll try to drive that one last rotation, and it'll just hang up. So if you're going to run into a wall, that use seconds and then let the time run out and go on to the next step. So then from here we wait 2 seconds, because after it hits the wall it's kind of bouncing, so this lets it stabilize. We back up slowly because we're doing precision turns here, and then we're doing seconds as we back into the lever, so that way it will complete the loop. Then we drive away from lever 1 and we drive into the wall again to reorient, and then from here we back out and we hit lever 2. Just wanted to provide this just as an overview so we can hopefully have some other teams competing with us and programming skills with our league. And thanks much. Bye-bye.